Hi, this is a quick walkthrough of the brand new QM30VT3 vibration sensor from Banner. We're going to walk through the different Modbus registers that are available from the vibration sensor, as well as how to utilize the VibIQ algorithm that is now built onto the sensor itself. To demonstrate the VT3, we're utilizing the DXM configuration software. A VT3 is wired into one of our DXM controllers. We've got some simple Modbus read rules coming in, and then all of the registers are labeled, units are put on them, and scaling is available. So we can begin visualizing some of the data that's coming in here. And what we start out with is the velocity and high frequency acceleration for all three axes, as well as the temperature in the first 7 registers. So they can all be read together as kind of the key characteristics for each vibe sensor. The velocity being utilized for determining the low frequency type of faults, things such as imbalance, misalignment, soft foot, and the high frequency acceleration being able to pick up on early bearing wear, lubrication issues, cavitation, gear mesh, etc. So beyond this big 7 that can all be read together, we've got some additional characteristics in here, such as peak-to-peak acceleration, peak acceleration. We've got crest factor, which is the ratio of peak acceleration to that RMS acceleration in the high frequency area. Kurtosis for the normalization statistical measurement of that high frequency area. Then we also have the crest factor and kurtosis across the entire bandwidth, not just in the high frequencies area. We've got the peak velocity frequency component. So this tells us where the highest peak is occurring within the 6 to 1,000 hertz range. So you can diagnose exactly on each axis where that highest peak is occurring at what frequency. We have an asset run flag that can be used. The sensor determines whether or not the asset is a running device or if it's off. In this case, it's off right now. If I turn on a signal and we start getting some larger data values in here, we can see that that asset run flag goes to a 1. This can be used for tracking amount of time on, energy usage. It also gets utilized by our VibIQ algorithm for determining when to take in a sample towards the baseline or towards an alert, and when to ignore it because the asset has been turned off. We've got full band peak acceleration frequency. So up here, we're getting the peak frequency for velocity in the low frequency band. Here we're finding where is the peak acceleration frequency, and that is across the entire bandwidth of the sensor. This magnitude register here is taking the high frequency RMS values that were in the first 7 registers, and it's combining all 3 of them, as the high frequency directionality is less important. So if you just want a single register to trend, this is taking x squared plus y squared plus z squared and taking the square root of that so that you have a single number to trend. We also have the full bandwidth RMS acceleration, so not the high frequency like we had before, but across the entire bandwidth, and in the event that you find that helpful. And then at the very end here, you can see that we've got the same registers that we had previously we have the same registers that we had previously in the first 7. These are repeated for metric. So this is in millimeters per second. This is still in Gs. So these are the same, but it just allows for an easier reading. If you're reading in metric versus imperial, you can take that one whole chunk all together. On the VibIQ side of things, we've got a number of different registers here, 39 in total related to VibIQ, and they are up in the 6001 area. We've got 1 trigger register and then 10 configuration registers here, some additional threshold registers for setting that run flag, and then we've got 18 additional registers that get set after a baseline is taken. We've got the baseline itself, and then the automatically learned warning and alarm thresholds for each axis on the velocity and high frequency acceleration. We also can set warning and alarm thresholds for temperature down here, and all of those warning and alarms get rolled up into these alert flag registers, which are bit packed and detailed in the technical note related to VibIQ. Now, to trigger a new baseline, all we need to do is send a 1 into this baseline trigger register here in 6001. We can see the status of it here and how many samples are remaining. We can set how many baseline samples we'd like. In this case, I just set it to 20 to keep it short for this quick demo. I've also got it set so that it's taking a sample into the baseline once a second. I would recommend having this a little bit longer, and our default on the number of baseline samples is typically 300. Having this at about 5 minutes or 300 as well gives you about a 24-hour runtime between all of those samples of a running motor. This here is for triggering the faults, and it's related to how many faults in a row, how many samples in a row, I should say, for the raw data to be above the thresholds before it triggers a fault. And then we have a 100-point moving average in the background for triggering a chronic fault, but this 100 points can be adjusted as well by a user. So if we go ahead and kick off a new baseline here, by writing a 1 into 6001, we can see that because I've got a simulated vibration source going in, we can see the number of our samples counting down. And as this value counts down, when it gets to 0 and that baseline finishes, this will change, but all of these numbers down here will also adjust when they are complete. And so we have a new baseline warning and alarm set up once we have finished that, and those will stay in there until a new value is triggered. So these can be read through once it's done, and you've got your alarms and warning thresholds there. And these alert flags can be viewed, and once we get to a spot where, like here, we are starting to trigger some alarms where we're right on the edge of things, those will start to trigger up. And as soon as the load goes back down below it, it will come back down. Now, if we're wanting to extend out how long it takes for those to trip and such, that's where the number of samples here can be adjusted, and having a longer sample rate there is also going to make it less volatile because it's only taking those samples in every so often instead of once a second.